Good day to all of you. Welcome to Easy Physics. Learn physics as easy as 1, 2, 3. Through this video, we are going to discuss about significant figures which you will be studying in class 11th physics as well as in chemistry. Significant figures are important when you express a measured quantity. While doing practicals in physics and chemistry, you will be coming across measurements, and while you express the measured values, you have to follow the rule of significant figures. Let's see what is the meaning of significant figures. Significant figures are nothing but the digits in a measurement which include all of the non-digits plus one estimated digit. That is, while taking a measurement, all the digits you might not be able to measure accurately, there will be a last digit which you may have to assume. Let's look into an example, then this concept will become clear. For that, I'm taking the example of a ruler, which is one of the very common instrument. It is used for measuring length. You all might be using it from smaller classes, right? So this is the picture of a ruler in which you can see there are certain small lines and some big lines. Each small line corresponding to 0.1 centimeter, as everybody might be knowing. And look at the measurement in this. I'm showing with the help of an arrow mark that this measurement is coinciding exactly with 13.3 centimeter, which means the length of this particular measurement is going to be 13.3 centimeter. But as per the rule of significant figures, along with the exact value, you have to write one estimated digit. Since it is exactly coinciding with 13.3, the estimated digit is going to be 0. So when you're writing the length of this measurement, you have to write it as 13.30 centimeter as per the rule of significant figures, right? Most of the time, while you take the measurements in a practical situation, it is very rare that the measurement will be coinciding with the graduated reading. Sometimes the value is going to be coming between two graduated readings. Let us look at another example in which the arrow mark is coming between 12.8 and 12.9, which means it is not giving you an exact value. So how to write the measured value in these cases? That first you have to write it is coming between 12.8 and 12.9. So the first value has to be written as 12.8. Then you have to estimate what is going to be the next digit. Since it is coming between 12.8 and 12.9, depending on whether the line is closer to 12.8 or closer to 12.9, you can choose any number between 1 and 9. Since it is showing a midway, I'm going to choose the number as 12.85, but it might not be the exact value. Sometimes it might be 12.86. So the last digit is going to be an uncertain number. It might not be the exact reading of the length measurement. Even though we have taken and explained by using a ruler, it doesn't mean that it is applicable only for ruler. It is applicable for any kind of measurements by using any type of measuring instrument. In the lab, you might be using a voltmeter, ammeter, or in a weighing machine, or in the chemistry lab, you might have to measure the volume by using conical flask, graduated cylinder, and so on. Let's have a quick look into a graduated cylinder. See, in this measurement, you can see the arrow mark is coinciding exactly with 56 ml. So while writing the measurement of this volume, you should write along with 56 one estimated digit. That is, the measurement value is going to be 56.0 ml. Or if the volume is not coinciding exactly with any graduation, if it is coming between, let us look into this example. The line is coming between 53 and 54, so you may have to write the value as 53.5 ml. So this is how you have to express measured value by keeping significant figures into account. Hope you all understood. Now the next topic is going to be, if a measured value is given to you, how to find out the number of significant digits in a measured value. For that, there are certain rules to be followed. Let us look into each rule one by one. The first rule says all the non-zero digits in a measured value has to be significant. It has to be always significant. See, for example, in the measured value 274, when you look at the number 274, it is having 2, 7, 4, 3 digits are there. And all these 3 digits are non-zero, which means this number is going to have 3 significant figures. Look at another example, 25.632. In this also, 2, 5, 6, 3, 2, all these are non-zero digits, which means everything has to be significant here. So the number of significant figures are going to be 5 in this case. If I give you another example, 8.987, I hope before I reveal the answer, everybody might have guessed it correctly. Yes, it is going to have 4 significant figures. So this is rule number 1. All non-zero digits are always significant. Now let us look into another rule. The second rule is about zeros. And there are 3 types of zeros. Let's say the first type of zero, it is called captive zero. Captive zero means it is nothing but the zeros captivated between 2 non-zero digits. For example, if you write the number 604, this is a zero, but it is coming between 2 non-zero digits. So this zero can be called as a captive zero. So as per the rule of significant figures, captive zeros are always counted significant. So if you look into this number 504, here to find out the number of significant figures, you may have to incorporate rule number 1 and 2. That is, 5 is a non-zero digit, 4 is a non-zero digit. The 0 is a captive zero, which means 1, 2 and 3, 504 is having 3 significant figures. Look into another number, 60,002. In this, 6 and 2 are significant as per rule number 1. And look at the 3 zeros in the middle. They are captive zeros. They are captivated between 6 and 2, right? So they are also significant. So the total number of significant figures in the number 60,002 is going to be 5. Another number, 9.077. Yes, it is time for you to guess and guess the correct answer. Yes, it is going to be 4 significant figures. Hope rule number 1 and 2 is very clear to all of you. Without wasting much time, we'll go to rule number 3. Rule number 3 says about trailing zeros. Trailing zeros are nothing but the zeros appearing at the end of a number which do not have a non-zero digit succeeding it. For example, when you write a number 60300, in this 0 is captivated between 6 and 3, so it is called as captive zero, whereas these two zeros are trailing zeros which are appearing at the end without having a non-zero digit followed by it. Trailing zeros, the rule is they can be considered significant only if the number has a decimal point. Trailing zeros are significant if the number has a decimal point. For example, if you have a number 32.0, this 0 is a trailing zero, but the number is having a decimal point, right? Which means that trailing zero has to be counted significant. 3 and 2 is significant as per rule number 1. So the number of significant figures in the number 32.0 is going to be 3. 19.000. All the 3 zeros are trailing zeros, but they are counted significant because the number is having a decimal point. So here the number of significant figures are 5. 105.0020. There are 3 captive zeros. This is one captive zero, this is another, and this is another. All of them are considered significant. There is one trailing zero also, right? But that is also considered significant because the number is having a decimal point. So the total number of significant figures in this number 105.0020 is 7. So we've spoken about non-zero digits, captive zeros, and trailing zeros in a number with decimal point. And let us look into rule number 4. It is also going to be about trailing zeros, but if the number do not have a decimal point, trailing zeros should not be counted significant. So trailing zeros has to be counted significant if a number is having a decimal point. If the number do not have a decimal point, trailing zeros has to be cannot be counted significant. For example, in the number 320, 0 is a trailing 0 and it do not have a decimal point. 320 means no decimal point. So that trailing 0 cannot be counted significant. So the number of significant here is going to be 2. In the number 19,000, all the 3 zeros are trailing. It do not have a decimal point, so number of significant figures are going to be just 2 in this. If it is 10500020, in this there are 3 zeros which are captive. Definitely that has to be counted significant, but at the end there is 1 0 which is called as trailing 0. So the number of significant figures in this example is going to be, yes, it is going to be 6. Now, let's see what is the rule for leading zeros. Leading zeros means these are the zeros which are coming at the beginning of a number. Leading zeros are never significant. Let's see one example, 0.0215. In this, there are 2 zeros which are coming before the starting of a non-zero digit. So these 2 zeros are called leading zeros. They are never significant, which means the number of significant figures here is going to be 3. 0.006. All the 3 zeros are leading zeros, cannot be counted significant, and therefore the number of significant figure here is 1. 0.00201. All the 4 zeros are leading, whereas this 0 is captive. So the number of significant figures here is going to be 2, 0, 1, which means 3 significant figures. Hope this rule number 5 is also very clear to all of you. We are going to the last rule. It is rule number 6, which will give you an idea about number of significant figures in a counting number and constant, which means when you do calculations, there are certain count. Like when you count a number, suppose you say that there are 3 ammeters. 3 is a count. Counts will always have infinite number of significant figures, or constants will also have infinite number of significant figures. For example, you know that in 1 hour there are 60 minutes, and this 60 is going to be a count, which means the number of significant figures in 60 minutes is going to be infinite. Or 12 inches, infinite. 24 hours in a day, 24 hours is going to be a count. So counting numbers and constants do have infinite number of significant figures. So all the 6 rules are very clear to all of you, I think. Let's feed these informations into your memory stack quickly. For that, I'm just going to conclude and give you a small package of what you've studied so far, and you can feed only this information into your memory stack. That is, first one is counting numbers and conversion factors are having infinite number of significant figures. Non-zero digits, always significant. Zeros, if it is leading zeros, they are never significant. If they are captive zeros, they are always significant. And if they are trailing zeros, sometimes they are significant. For that, you have to ask a question whether the number is having a decimal point or not. Decimal is present or not. If the answer is yes, which means it has to be counted significant. If your answer is no, which means you don't have to count it as significant. Hope this is very helpful to all of you. If so, let's have a quick recap and see whether you are able to find the answers of the given question. How many significant digits are there in the following numbers? Quickly say. 0.0073. How many? Yes, two significant figures. 100.020. How many significant figures? Yes, it is having 6. 2500, only two significant figures. 7.90 into 10 raised to minus 3. It is having three significant figures. 670.04. 0.00001, just one significant figure. 18.84, four significant figure. Hope all of you were able to guess the answers along with me. If so, yes, you are good at counting the significant figures. Thank you for watching me. Hope you all enjoyed and learned how to calculate the number of significant figures in a given number. There are certain rules to be followed while you do arithmetic operations with regard to significant figures that we will be describing and discussing in one of the forthcoming videos. Hope to see you soon. Hope all of you have enjoyed learning significant figures. Keep watching and subscribe my channel if you did not do so. Thank you for watching once again. Have a great day to all of you.